So the curve C has equation y equals 16 root x plus 32 upon x plus 2. And in A, it says find the value of dy dx when x is 4. So before we actually find the value, we need to work out the gradient function dy dx, okay, before we sub x equals 4 into it. And I've got y here, okay, it's y equals 16 root x plus 32 upon x plus 2, okay. Now before I find dy dx, I need to sort of write this in a form that I can work with. So we need to appreciate here that root x is x to the power half, yeah? Square root is written as power half. And then with x on the denominator here, I need to take that up to the top. So it becomes 32x to the negative 1. Okay, because it's positive 1 there. Take it up, it becomes a minus, and then plus 2. So if we do dy dx, well, you bring that power half down. So half comes down. Half times 16 is 8, yeah? And I bring that down. X then, and I take away 1 from a half. If I take away 1 from it, I get minus a half. Okay, and then same here, bring the power down, minus 32x, and then take away 1 from that, it would be minus 2, and then u plus 2 is a constant, so you differentiate it, and it becomes 0. So I've got this, okay. Now, of course, we could use this, and we could work out then what dy dx is, when x is 4. We could put it into our calculator, but it's helpful to sort of write this in a nicer form to make it a bit easier for ourselves. So if you appreciate here, because the power is negative, we could write that as, we could take it down to the denominator, okay, and the same here. You could take this down as x squared, and then that's x to the power half. And then you appreciate, of course, that on the bottom here, because it's x to the power half, that can be written as square root of x, and then minus 32 over x squared there, okay? So now we can work out what dy dx is when x is equal to 4, okay? So when I put x is equal to 4 in, dy dx is equal to 8 upon root 4, take away 32 over 4 squared. So if I work that out, okay, you can use a calculator. So you get 4 there, that is 2, 4 take away 2 is 2. So we get dy dx is equal to 2. Part B then, it says, find the equation of the normal to C at the point where x is equal to 4, okay? So think about what we've done in part A. When x is equal to 4, we worked out dy dx to be 2. That is the gradient of the tangent. If I want to get the equation of the normal, I need to get the gradient of the normal, don't I? This is the gradient of the tangent, but you just need to appreciate, just like before now with the sketch, if I got my tangent here, okay, if I got my tangent there, my normal is perpendicular to it. The normal is perpendicular to it at right angles, okay? So if I've got my gradient of my tangent to be 2, I can then work out the gradient of the normal. So using m1 dot m2 is minus 1, okay? My tangent is 2, and then I can work out the gradient of the normal. So take the 2 over, so I get minus a half, okay? So that's the gradient of the normal. So once I got the gradient of the normal, I can then work out my equation, okay? At the point where x is 4, yeah? Okay, because I've got the gradient of the normal here, which is minus a half, and I've got the point x is 4. Of course, I need the y value as well, don't I? So I need to work out what the y value is. So I could say then, okay, so when x is 4, y is equal to 16 root 4 plus 32 upon 4 plus 2. And of course, in an exam, you use your calculator on this, right, to make sure you're getting this right. So we've got, let's work it out. So we've got 32, my calculator's not working, 32 plus 8 is 40, 42. Okay, so that's what the y value is there. So then we've got the equation of the normal. Y minus y1 is mx minus x1 be y minus 42 equals the gradient, which is minus a half, and x1 is 4. Okay, so we'll take the 2 over, expand the bracket, 2y minus 84, and then expand that bracket, minus 1 times x, minus 1 times minus 4 is plus 4. So I get 2y plus x is 88.